Hi guys, today we'll look at implicit differentiation. I know this topic is very confusing to students or to learners, but today I will try my best to do justice to it. Welcome to my YouTube channel, Calculus 360. You can subscribe to my YouTube channel. Now, we're asked to differentiate the following implicitly. X squared plus y squared equals to 4, x squared y plus y squared plus 4x equals to 1. Now when we talk about implicit functions are just those functions that has more than one variables combined, while explicit are those functions that have just one variable. Example, differentiate y equals to x squared. You're differentiating y with respect to x, of course, that's an explicit. Differentiate y equals to a square. That means you're differentiating y with respect to a. That's also an explicit. Now, implicit, like I said, you have two variables combined, x and y, and same with this. Now, how do we solve the first one? All we need to do is to differentiate each of them. So we have x squared plus y squared equals to 4. Now we differentiate this with respect to x, so we have this with respect to x, plus we differentiate y squared also with respect to x. And we'll also do the same thing for the constant. We differentiate 4 with respect to x. Now if I differentiate x squared, I will have 2x plus, whenever I differentiate y with respect to x, the dy over dx will retain. Okay, because dy over dx is the differentiation. So whenever I differentiate y squared, for example, y squared is 2y. So because this is dy over dx, which is our differentiation, it will multiply the 2 and we'll be left with 2y dy dx. Okay, is equals to the differentiation of a constant is always 0. So now from here I can make I can collect the like terms. So if I do that, I will have 2y dy over dx is equals to 0 minus 2x. So this will give me 2y dy over dx equals to minus 2x. If I divide both sides by 2y, I should have 2x over 2y. I can as well reduce, and this will give me minus x over y. I can just cancel out the 2, I'll be left with minus x over y. So this is the differentiation of this implicit function. We also call this the first derivative, because dy over dx is the same thing as y prime. That's the first derivative, and it's still the same thing as n prime. So if I differentiate again, I should have d square y over dx square, square y over dx square, and this will give me my y prime prime, and this is the same thing as my n prime prime. Of course, remember that slope, which is n, is the same thing as differentiation. If I differentiate again, I should have d cube y over the x cube, which is the same thing as y prime prime prime, which is the same thing as n prime prime prime. Okay, so when you keep on doing that, you still have, it follows that pattern. Now let's see how we can do justice to the second one. For the second one, you are asked to also differentiate this. This is also an implicit function. So first, since we have x squared y, means we are multiplying x squared and y. So you can actually multiply x squared times y or y times x squared. So whichever one comes first. So all we need to do is to keep our x squared first and differentiate the y. Plus I'll keep my y and differentiate x squared. Then plus, I'm done with this. I'll move to this side, I'll differentiate my y squared. Plus, I'll move to this 4, I'll differentiate my x. Because we have 4 times x, which is same as x times 4, I can still go ahead to keep my x and differentiate my 4, which is equals to my differentiation of my constant. Okay, this is what we have. So once I differentiate this, y, remember I told you once you differentiate y, it still retains the dy over dx. So I'll have x squared dy over dx plus, when I differentiate this, I should have 2x. So 2x times y, this will give me 2xy plus, also the same thing, when I differentiate my y, I should still retain my dy dx. So this will give me 2y dy dx plus, if I differentiate my x, I should get 1. 1 times 4, that will give me 4. If I differentiate my constant, I should have 0. 0 times x, that's 0. It's equals to, if I differentiate that constant again, I should have 0. Now, I can collect the like terms, so I can see dy dx and dy dx, so I can bring them together. So I'll have x squared plus 2y dy over dx is equals to, so I can take the other one to the other side, this other one, so I'll have minus 2xy minus 4. Okay, so I can just decide to put them in brackets. So I should have something like this. So from here, I can divide both sides by x squared plus 2y because I'm looking for my dy dx. So dy over dx is equals to minus 2xy plus 4 over x squared plus 2y. And that's my dy dx. If you like this video, please share, comment, subscribe, of course, to see more of our videos. Thank you.